Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
This is continuation of the previous problem about the pulley hanging from the ceiling and two body M1, M2, M1G, T, M2G, T, X here, acceleration A. We assume that acceleration, this body is moving up and this body is moving down. And the result that we received, we got acceleration and we got tension. And I want to discuss those results a little bit because one thing, we got equations and we got the results, and another thing, we want to validate if those results present a common sense. And first of all, of course, the equations for this body on my right is T minus M1G equal MA, and for this body that's going down, it's M2G minus T equal MA. Alright? And yeah, I wrote this for this X going up, and X is here. I was solving it with X direction of this X is up, but if I put X down in this solution, this would be correct, because M2G minus T equal M2A, and this is the same like in previous solution, only I forgot index 1. So this is the thing, and then we receive this. Let's do several validations. First of all, I forgot. See how I wrote this? I wrote this with this ratio, mass on the top, mass on the bottom. So this ratio has no units, because kilograms on the top and kilograms on the bottom, they just cancel out. And so this is just a number. And G is acceleration. So I have that A is some portion of acceleration G. Right? And it's very important because I immediately see that the top of this fraction is always less than the bottom. So this number in front of G is always less than 1, because I divide smaller number over the bigger number, and I receive something less than 1, and so acceleration is like a portion of G. It's very important. And likewise, I wrote it in such a form that this is mass squared, and this is mass in the first degree. So in terms of units, this is mass multiplied by G. So this is force, because we know that unit of mass multiplied by unit of acceleration is always Newton, is force. So that's nice to write it, and there is another thing why it's nice to deal with the ratios. First I just dealt with the ratios, showing that result is a fraction of G. But there would be another thing that I will let you know in a second. But first, as I said, let's do some sanity checks. Some sanity checks imagine that M2 equal M1 equal M. Same as here, so what will happen? Of course nothing will happen. They will be hanging in total balance. But if they will be hanging in total balance, their acceleration would be 0. And of course, M2 minus M1 would be 0, so acceleration will be 0. That's a good thing. What about tangent? Tangent, this body, T up, M1G down, and they completely balanced because this part is 0. This body, M2G down, T up, and they completely balanced. So we can of course say that that in this case A equals 0 and T equal mg. M1, M2, it's the same like mg. Tangent balances the forces, everything balanced. Now, We already checked that formula gives us A. Let's check that T is giving us the same number. We have 2, M instead of M1, M instead of second one, divided M plus M would be M plus M, G and T would be 2M squared divided over 2M over G, and T would be mg. So we received what we wanted to receive, and this is good. That means in the case of equal masses, everything is balanced out, and T is equal this mg, and everything is fine. Now, when masses are not equal, we of course know that this formula shows us that T on this side is a little bit bigger than M1G and pulls it up. I am considering that M2 is greater than M1, just for simplicity, right? So I will dealing with the positive numbers, and everything is going exactly as I suggested, which was my guess, exactly as we guessed in the beginning, that A is directed that way. And so what we have here, we have that T is a little bit bigger than M1G, but M2G is a little bigger than T. So if we use the line, the numbers line, should be 0 somewhere, should be M1, should be M2, and somewhere M by G, let's put it in terms of force, and somewhere here would be T, just between M1G and M2G. So T minus M1G would be positive, pushing it up, M2G minus T would be positive, pushing it down, pulling it down, so everything seems okay. But our formula, does this accommodate for the same stuff? In particular, M1G, and this formula, 2M1, M2, G, M1 plus M2. Well, we know that this should be like that, but I'm looking on the mathematical problem, and I have an inequality, and I don't know which way is this located, this way, that way. So I put this greater sign. For the time being, is I leave it as nothing, or other people like to put it this way, so it's pointing that or that, I will find in a second. And of course, G, let's prove it. G is gone, multiply both sides, M1 plus M2, so this will be gone, and here M1 plus M2 would be here, right? It says I'm multiplying this on this and multiplying this on this, and this bracket is gone. Or I simply mnemonically remember that I send this from denominator to numerator on another side. So this and this is 2M1 M2, and then I open brackets and I have M1 squared plus M2 M1, and I don't know what it is, and I have 2M1 M2, and M1, M2, all are positive numbers. When you're dealing with inequality, it's always important not by accident to multiply a negative number, because then this would be not an equivalent transactions, not equivalent transformations, but M1, M2 is positive, so I see M2, M1, M2, M1, so I have one apple here, two apples here, I see this, I see M1, M2, and I see M1, M2, and I say M2 is greater than M1, so I put everywhere and this is my side, right? My side of a story, and I have, if M2 greater than M1, that absolutely means that this is greater than this, what I wanted to prove, right? Because I can repeat all the transformation in the back order, and from valid one, valid one, valid one, valid one, valid one, I have that t is greater than m1. And of course, if they are equal to each other, I cannot say this, it would be equal sign, equal sign, equal sign, equal sign, but let's forget it. Equality, we already talked about this. We know that m2 and m1 not equal to each other, and that means that t, this number, is really bigger than this, which is nice. And likewise, I can compare this with m2g. And forget about those, I just don't want to remove this, but maybe I will, because maybe I will keep it. So, and I don't put here nothing because I don't want to wipe it out, just keep it empty. So m2g, I multiply both sides on this bracket. So if I multiply, I'm looking only here, then it will be 2m1, and here would be m, and g is gone, and I have, because g is gone here, and I have m1 plus m2 multiplied by m2, and I have this as this, and I open brackets, and I have m1, m2, and I have plus m2 squared, and this is gone, and I have m2 squared, right? And then the only difference that I want now to, previously I divided into m1 and I got m2 greater than m1, and here I divide into m1, so it would be m1 less than m2, and then I go up, and I received, yes, that this number is always between m2g and m1g, as it should be. And that's a very nice observation too, and that basically tells us that all is good, and t is right between m1g and m2g, and it keeps the tension in the rope, and the tension in the rope is enough to overcome m1g on this side, but not enough to prevent m2g to send it down here. Alright, and then the last thing I want to talk about is extreme case, extremality, because it's very, let's compare what happens if m1 is significantly smaller than m2. I don't know, 1 gram, and here is 10 kilograms. Of course this will go. So what will happen if this would be the case? If this is 10 kilo and this is 1 negligibly small, well, this 10 kilo will go down with free acceleration g. So if m2 is very big number, it goes very fast down, because this is nothing. Whether it's 1 gram, 2 gram, who cares? This m2g will be sending down everything, and this will fly with acceleration g. Let's look on this formula to see if this is the case. And what we do if m2 is very big, we will rewrite this formula. It's a typical way. m2, and here would be 1 minus m1 over mt. Why I divided, why I factored m2 from the top section? I factored m2 because I want to deal now with ratios m1 and m2, and I know this ratio would be negligibly small. So I did this, and on the bottom I factor m2 again, and I will have 1 plus, sorry, it would be not 1, it would be m1 over m2 plus 1, right? Because if I multiply this by this, I will have m1, and if I multiply this by 1, I would get m2, and of course g will stay like this, and then this will be gone, and they would be, look what will happen, 1 minus extremely small number, and on the bottom would be 1, I change the order, plus this extremely small number, and multiply by g, and it will be approximately g, because it's probably 1 a little bit smaller, it's probably 1 a little bit bigger, so this ratio would be very close to 1. I don't know, no 0.99, divided 1 over 1. Well, it still will be very close, something very close to 1. So, if this is the case, I have again correct answer. That very reasonable that when this force M2G mass M2 is bigger than M1, M2G is much bigger than anything else and it falls down. Let's take a look what happens with T. Because in order for that to fall down, T is supposed to be very, very small. Again, I take this second one, T, and I again want to deal in terms of those ratios. So I say T equal, and 2m1, m2 is 2m1, m2. That's okay. I cannot do much. But on the bottom I take m2 out. I factor m2 out because I want to have this ratio of m1 to m2, and this ratio is a very small number. And I have to have plus 1. And I have G, and m2 is gone, and T equal 2m1G divided over very small number, m1 over m2, and I probably can say that this is 1, and I say that it is 2m1G. 2m1G. So T is very small, because we know m1, T is very small comparable to m2G, because T is 2m1G, and this is m2G, and this is gone, and 2m is significantly smaller than m2. So yeah, m2G has no resistance from T. The body is practically falling under gravity and no T, because T is negligibly small in this case. Negligibly small. What happens with other body? Other body tension is 2m1G. So 2m1G up, m1G down, and the body goes up with acceleration very close to G. Of course, it's not G, it's a little bit less because we're dividing into a very small number. But for brief estimate, yeah, this moving down almost with a G, this moving up almost with a G. To move up with almost G acceleration, this has to overcome this, and it has to be twice. 2m1G minus 1 would be m1G, and that means that the body, right body, is going up with G. And I hope this was extra. This was for those of you who wants to know really deep. Most of the time your teacher would be happy with this, or your test question would be to find that and plug the numbers, 1 kilo, 2 kilo, whatever you have. But this is like a deep explanation of real physics. It's how real physics works. We have the model, we put the forces, we have the equations, we solve those equations, and we have to think. Our equations have meaning, and yes they are. And are they correspond to the common sense? And in this case we like it. And if they would not be corresponding to the common sense, I would have to go through backwards to find where I did a mistake. And that's what you should do. Pause it, think about it, come to it hours later, repeat those things, review my video again, make many pauses, compare results with what you done, and I hope this will be very helpful for you. Thank you.